Hello everyone. In this C++ programming tutorial, I'll be introducing to you a C++ program that will be used to test if the number entered by the user is a prime number or not. So starting with the meaning of a prime number, this is the number that has to be greater than 1, and this number has only two factors. That is themselves, the number itself, and 1. So a prime number cannot be divided by any another number without leaving a remainder. So now we have the concept of remainder that in programming we call it the modulus. So an example of a prime number is 13. This 13 can only be divided by 1 and 13 itself. There is no any another number that can divide 13 apart from 1 and 13. So a factor is the number that divides another number without remainder, without leaving any kind of remainder. So a good example, the factors of 12 are 1, 2, 3, 4, 6, and 12. That means all the listed numbers here, they can divide 12 without remainder. The factors of 8 are also listed here. The factors of 16 are also listed here. So that means, of course, in short, what we can say is that 1 and the number itself are the factors of that particular number. Another example, I can say maybe the factors of 5 are 1 and 5. The factors of 7 are 1 and 7. The factors of 13 are 1 and 13 itself. So we don't have any another factor apart from 1 and that number itself. For this case, 1 is always a factor of any number. Any number that we write is divisible by 1. And also that number itself is also divisible by itself. 16 divisible by 16, 5 is obviously divisible by 5, 7 is obviously divisible by 7, and 13 divisible by 13. So that means if I have other factors apart from 1 and that number itself, then the given number is not a prime number. Example 12 is not a prime number, 8 is not a prime number, 16 is not a prime number. But 5, 7, and 13, these are good examples of prime numbers since we only have two factors, that is 1 and itself. So let us now head to the programming part. I'll be declaring my variable here called int n, that is the number that I have. And then now prompt now the user to enter a number, and then I'll be capturing the value of number. And then now let me just initialize the factor. And I set this the value of factor to be 0. This will be an integer data type. So I have initialized the value of factor to be 0. That means at the moment, I don't have any factor of a given number. So then now I have to start now looping for bracket int I. Now I start looping from 2, since 1 is already the factor of that number, and the number itself is also the factor of itself. So I don't want to test for 1 and that number itself. So I'll just only be testing from 2 up to that number minus 1. So I'll be testing up to I is less than n, and then I'll be incrementing the value of I, and then I'll be now testing the condition. If the value of n modulus I, if is equal to 0, then that means I is the factor of that number of n. So that means the value of factor now will be incremented in one way or another. So to see, let us just dry run this one without, let us assume that the user's input at this point, let me just assume the user's input is 10. So then we'll be testing the value of n modulus I is equal to 0. Our I is 2 and our n is 10. 2 is less than 10, that is true. But 10 modulus 2 is equal to 0, this is true. So the value of factor here will no longer be 0, it will be set to 1. Then we increment the value of I, and the value of I becomes 3. Of course, 10 modulus 3 is not 0, so the value of factor remains to be that way. Again, we increment the value of I, and the value of I becomes 4. But again, 10 modulus 4 is not 0, so the value of factor remains to be 1. Again, increment the value of I, the value of I becomes 5. 10 modulus 5 is equal to 0, so the value of counter is no longer 1, and now the value of counter becomes 2. Now, since our program, of course, here will end when I is less than n, so the program will end when the value of I is 9. So I've just tested for 2, but you can just try run and see the value one step after another. So at this point, I can now see the factors of a given number. Example, if now I go outside this for loop, and then if I just see out the value of factor, the value of factor, and then I just end the line. If I input the number 10, I expect to see 2 as an output. Let me just input 2. I have 0. Sorry, I did have also, sorry, I have to input 10 so that I can test it. So I have 2, and the 2 is the one that we have found from the part that we have dry run. But now let me just try, of course, let us try 13 as the number that we have. 13, we have 0 factors because we haven't tested for 1 and the number itself. That is the point that we need to remember. You can also test for them. If the value of factor is 2, then you do that way. So this is the way number 1 that I'll be testing. I'll be testing from 2 up to the value of I minus 1. So you can also change this. Of course, there is no problem. Let me just start from 1 up to I is less or equal to n. And then from this point, I'll have the value of factors. See out. I just wanted to say here that I have the n, and then I have the text has, and then here has factors this way. Let's test that way. Of course, there is also no problem. Let me just enter number 10. This number 10 has 4 factors. 10 of course has 4 factors. Number 1 is 1, and then 2, 5, and 10 itself. Let me also try for 13. Let me also test for 13. 13 has only 2 factors, that is 1 and 13 itself. So if I have only 2 factors, then the given number will be a prime number, that is 17. It has also 2 factors. So that means for this case, now for me to say that the number is prime, the number is supposed to have only 2 factors. So here I'm going to say if the value of factor is equal to 2, then see out the given number is a prime number, and then I just need to end the line that way. Else that means now the value of factor is greater than 2. Now the value of factor is 3, 4, 5, 6, 7, 8, blah blah. Then the given number is not a prime number. Since we have more than 2 factors, is not a prime number. So let me just run it and see what happens. So I just put 12. 12 is not a prime number, and I agree with it. I just put 177. This is not a prime number, it has a factor. 1415 divisible by 3, of course. And I can just put another number, maybe 17. 17 is a prime number. So as you can see here, if I have 2 factors, then the given number is a prime number. If I have more than 2 factors, then the given number is not a prime number. Example here, if you can see 12, we have 1, 2, 3, 4, 5, 6. We have 6 factors. So that means 12 is not a prime number because I don't have only 2 factors. So guys, thank you so much. If you have any question, please don't forget to write your question in the comments so that I can provide a further clarification for this one. And this is the simple program that I used to have for testing whether the given number is a prime number or not. Thank you.